technical experiment number 6 is the water level control. So what can you do here? We have a bottom basement and an upper basement, and the task is to regulate the water level in the upper basement. And therefore we have a couple of different options. We can do it manually. Here we have two pumps, a pump in the bottom basement which can pump water to the top basement, and we do have a pump in the top basement which can pump water down to the bottom basement. Also a valve or a tap to confuse the system, so we can pour water from the upper basement into the lower basement. And here at the top we have the control system. Now the control system we can control using our mobile device, either the smartphone or the tablet. I will show you in a minute how that works. But let us first have a look into the upper box, which components are inside there. So we do have a power bank which is currently powering the ESP32 microcontroller. That's the brain of the whole system. There we have an ultrasonic sensor. We have a power supply for the pumps because they need 12 volts and the ESP32 only needs 5 volts. And then here we have two switching modules to switch on and off the pumps. So we have some cables here coming from the pumps and some cables from the microcontroller going to the switching modules to switch on and off the pumps. So now let us log into the system, and here we do have the information card for the experiment, and there you can see it's our 6th experiment called the level control for the topic of energy and water management. This is the group yellow. There's an IP address and a password. So we need to log into the Wi-Fi of this microcontroller, meaning we don't need to log into the Wi-Fi of the university here or into the mobile data, but this ESP32, this small little piece here has its own Wi-Fi. So now we want to log in there. So we go to the Wi-Fi setting of our mobile device, and there in the list of possible Wi-Fis to connect to we find the technical experiment number 6 water level control with group yellow. There we go. Now we need a password, and we can have a look what the password is. It says 06 yellow. So let us type 06 yellow and connect. Perfect. Now we are connected. But don't be disturbed by your device now telling you that you don't have internet connection, because we don't need internet connection. Now this device is connected to this Wi-Fi of this experiment without the internet having access to either the experiment or my mobile device. But I don't need that. I can open now the website which is stored here on the ESP32 through the IP address given here on the information card. So let us open the web browser, and there we type in, what does it say? 192.168, 192.168.4, I guess. Yes, 0.4.64. And there we are. Now we are on the website of this experiment. And here now we can set what this experiment should do. So we have a button which says pump up, and there the water is running, or pump down, and there's the water is running. So now the task is to keep the water level constant, meaning if someone opens the valve, so if this upper basement, for example, would be a YOLO tank sitting somewhere on a tower providing the drinking water for your domestic home, here someone in the kitchen could open the tap because he needs water, and now the water level is not constant anymore. So someone needs to press the button and refill the upper tank. So if you use the manual mode, you need to employ someone and you need to pay wages for him to sit there the whole day and watch the water level going up or down and then quickly pressing either the one button or the other button. And that would cost a lot of money, and for that person sitting there it wouldn't be such an interesting job. So you have other options, for example the 2-point controller. Now if we switch to the 2-point controller, there are some values which we set, and now the system itself tries to reach that value. Now you see it's nearly there, and now it tries to keep that level. If we drain water, we see automatically only the pump is running to pump water up into the top basement. If we close the valve again, it fills the upper tank to the specific level, And what happens now? The system starts to be unstable. So both pumps are constantly running. Let me switch it off. It's making such a noise. But this is also not energy efficient. Both pumps are constantly running, one pumping down, one pumping up. That doesn't make sense. So we need to find better settings. But what is the problem with our two-point controller in the moment? Two-point controller means we have 2 points. If the water level goes above the top point, the upper pump will start pumping water down because we are above the set water level. The second point, if the water level drops underneath that point, the bottom pump will start pumping water up because we haven't got enough water in our upper basement. So these 2 points now in these settings were set with only a millimeter difference. So the water, because it is pumped inside, it shovels a bit and it easily goes above this and underneath these 2 set points we have because they are so tight to each other, only 1 millimeter. So that's why both pumps start running. So let us try to change the setting to maybe 5, or let's take 10 millimeters, 1 centimeter. So we changed the value of the bottom from 75 to... So we change now the value of the lower minimum value from 79 to 70. And we say activate. Now the system is quiet, even though we're using the two-point controller. Now, if someone opens the tap in the kitchen, we can see immediately the bottom pump starts to refill the upper basement. And if someone closes the tap again, and the water level is again there where it should be, the system is silent. So the 2 points we set with a 10 millimeter difference is still not enough because sometimes it still starts to be unstable, the system. And that is a typical case you have in any controlled system. So you can show your learners what it means if you haven't set your controlling parameters in a correct way and the system starts to swing and to be uncontrollable. And you don't want that because that is not energy efficient. For example, at your domestic home, if you have a heating system and the heater switches on and off, and then the aircon goes on, and then the heating system, and then the aircon, because it can't keep the temperature you want in your home, that wouldn't be good. So you can really show what it means and what happens if it's not set in the right way. But we've got a third option. And the third option is the PID controller. Now there's a different set point send. And here we can see it's still swinging, but not as badly as the previous one was. So what is different with the closed loop PID controller to the previous 2 ones we used is that we implemented a PWM, meaning the pumps not only know only off and only on, but they know like a bit on and a bit off, meaning the water is not running like full power, but we can switch the pump from pump a bit to pump fully as strong as you can. So this PID controller needs also be set, and that is a bit more difficult than the other ones because you've got 4 variables you need to set in the right way. You need to start in the right order. The PID controller is the most commonly used control method for systems which need to be controlled. You can really dive into the different parameters. You've got 4 variables, where to start, how to change them, what are the maximum, the minimum values you can choose, and also what the different parameters mean. So what is the P part, the I part, and the D part? And there you can either come from theory, making it practical with your learners, or coming here from the practical setup that they see the relevance of this theory. So if you then go back to your board and you do a theory lesson about controlling systems, they know, okay, now I need to be careful, I need to listen because I can see I understood why it's important to know such systems. From a cost point of view, this might be our most expensive experiment. We have 2 pumps, we have a lot of boxes, we have got a lot of electronic parts, as I said already, as I have shown you already, the specific parts. So this whole setup costs around 90 euros for the European market, which is about roughly 1,800 South African rand. What I really like about this technical experiment is the water part, because it usually splashes. So you must see the learners. First of all, they have their books, their paper stuff lying around, and then it starts splashing. And then either they start collecting all of that, or they don't realize, and afterwards they're like, hey, everything got wet. So I like it to play a bit around with water, and even if it's a hot day, it makes even more fun. So this is only one of 9 experiments we developed. If you're interested in the others, you can either watch our playlist here on YouTube or check the description down below. There we provide you the link to the university's website, and there you can download the schematics, the code we use for the ESP32, and additional information. So if you want to rebuild this, you only need to buy the parts, and the rest you will find on the website. And yeah, have fun with it and splash around.